Hello. How's
Yo,
Argentina?
it's a little colder than Philly. How's Philly doing? I heard there's some issues there too.
Hot here.
Hello, everybody, and welcome to episode 85 of Community Service Hour, broadcasting live on YouTube, Twitch, and Twitter Spaces. On the agenda, we've got two items to check out. One of them is Movement Labs, and another one is tracking authenticity of images. But first, all right, let's check out Movement Labs. This is talking about Move blockchain, and let's get this white paper up. And my lights just went out. Am I still on the internet? This is a first. We've never actually had a power outage in the middle of community service hour. So movementlabs.xyz. I've seen this kind of idea before. So I wanted to look at this and come at it critically, come at it holistically, and see what they're pitching, their experience firsthand, problems with accessibility for getting onto blockchain stuff. We all have. Their vertically composable network is working with Avalanche and other future ecosystems. Okay, so they've got a specific blockchain and they've got an ecosystem and they want to go vertically on this. Okay, what are they doing? Modularity and interoperability to non-EVM smart contract languages. Non-EVM smart contract languages. Doesn't Avalanche use EVM?
No, it says supports EVM.
Okay. Well, technical note aside, number one, L1 built is on Avalanche. They're pitching a stack, a tech stack that kind of works with Avalanche, Avalanche Go, work messaging, Hyper-VM to solve the cold start problem with unprecedented interoperability. And they're saying is it's hard to get started on Avalanche and non-EVMs. Facts. They want to help you. Okay. They want to vertically integrate. Good. But then they also want to support multiple blockchains. No. The solution to this is too difficult is not let's make this more difficult. So that's the problem that we're trying to solve here. Scrolling down to the second part of a long landing page. Ready to onboard the next generation. Okay, so now they go into what are the applications that they're trying to target. DeFi, gaming, NFTs, and day zero partners. Partnering with DeFi primitives to support a robust day zero. And Avalanche Consensus provides near instant finality for the most optimal DeFi. Okay, so this is maybe an L2 that's going on top of Avalanche. Maybe this is Avalanche's L1, and this is a non-EVM L2 on top of Avalanche. Okay, for the purpose of doing DeFi, and then it just goes straight into join the community. So I've seen a lot of projects like this before. And so I wanted to look at this because someone cool sent it to me, and I look at stuff that they send me for sure. And I also just wanted to, for movement, for other people like this, and maybe this will be the hot take episode, and then later when we figure out how successful they are or whatever, you can contrast it and be like, wow, Will was off the money on that one. But prove me wrong. So the first thing I see here is that do you really need a cross-platform solution when you're making a vertically integrated product? So if the product is games, do you really need multiple chains to do games? Opposite of vertical integration, horizontal and vertical integration is just n squared effort, right? The whole point of vertical or horizontal, that's just called everything integration. If it's vertical and horizontal, what depth, is that the only thing you're missing? So 2 days that I was reviewing Aeon, I guess I can't pull that site up, but Aeon is a was a Java-based blockchain, very similar to Ethereum, modeled off of Ethereum. The difference is that they used 128-bit numbers instead of 256-bit numbers, and they did everything using Java. So totally different. And I looked at it and I said, okay, well, the first thing when I see a project that's not EVM and it's coming from scratch is, how much money do you have? How many engineers do you have? How long have you been working on this? Because there's a lot of effort that went into EVM and a lot of people that have tried to break EVM. So if I see you have less than 20 people making your own virtual machine using Java, and you don't have 100% test case completed, test coverage, I'm like, okay, let's get hacking. And sure enough, I was working on Aeon for the first few weeks. And one of the first major bugs that I found was that I could just steal anybody's tokens on the entire blockchain. That's not something you want. You don't want to launch a blockchain where people could just steal any of your tokens. But sometimes when you're building a blockchain, you're thinking, oh, I need this feature, I need this feature, I need this feature. And then you have this like Asana board, and the CEO puts features in there, and you build the features, and then they work, and it turns green, you get money, and you get paid, right? That's blue team. Where's your red team? Your red teams be like, oh, you forgot that I can, yeah, the token sending works, but anybody can just take the tokens. So to actually have the blue team and the red team and all the things you need to have a trusted network, you got to have some time and money for that. And that's the technical thing. Now, the business thing is, if you're going to spend a lot of time and money on something, you better get something out of it. People saying, well, we want to run bigger applications. No, you don't. The whole point of blockchain is to put succinct stuff in there and get succinct stuff out. If you're trying to put all this stuff through a blockchain, you're doing it wrong. And when you're replicating databases as much as blockchain, there's just not enough room for all the business data in the world. You cannot put Visa on blockchain. It doesn't work. Maybe like when I'm reading an EIP. I saw an EIP, it was 6558, I think, about a very complicated way of doing NFTs and having NFTs be smart contracts, and then why would you want to do that? And there's a diagram of like 4 layers of indirection between the NFT and who gets the NFT. And I'm like, okay, you've articulated a really complicated solution. Why? And the reasons they come up with were just so like, if you did this, you would need the solution. Or maybe if you needed that, you would need this solution. It's not a hammer looking for a nail. It is like a nuclear power sub looking for any type of water. Like, you don't build nuclear sub. First of all, nuclear power is about the driving. I'm seeing nuclear power. It's cool, but and it can work, and we can make it work, and we can red team and blue team it, and we can fix problems, and we can make it production ready. But I would really like to see a business justification where you're like, this is something we need because, and don't tell me TPS is too low. Don't tell me you want to run a whole Java program. And that's just a misunderstanding of, that's like seeing people bastardize and abuse technology. It's like MySQL is a database too, and people use it in Oracle. And you can put programs in there, but like the wrong way. And this may or may not be technology that the Navy uses when I was there. Like, you shove a whole program into the database so that anytime a row is added, it does all this stuff, and then it, the way you want it. And that's fine. You can do this for like a couple small things. An entire business program in there, that is not the way databases are designed. And DeFi on top of Avalanche, I hope Avalanche is paying good money for this, because how many tokens are there on Avalanche? And Avalanche is so expensive that you can't run DeFi on it, that you need an L2 on top of Avalanche that's not on EVM. Like, there's just so many like layers of difficulty here that I'm not seeing it. Like, you've got compound finance running on Ethereum mainnet, and that works. And you can do it on L2, but you're not doing it on like a Java network on top of Ethereum. That's not working. I have nothing bad to say about gaming. Maybe do a game. If you have the vertical integration already, if you have clients in the gaming industry and you have large clients and they need to have, do it. I mean, that makes sense.
I'm with you on everything. They proposed 2 other use cases, NFTs and Day Zero partners. What do you think about their proposal for doing this with NFTs?
When I read the word gaming, I'm assuming that means NFTs.
It's the same.
I'm assuming they're just double dipping the word.
Get it? I don't know who would care enough at this point. They're trying to do. This came from a trusted source.
Yeah, it came from this is by an ecosystem of tools for creating the smart contracts. Basically, a lot of the tools that people are used to in Ethereum land, EVM land, they are talking about for moved blockchains. And topic for today, this is called C2PA. And so this is the
Coalition for Content Provenance.
Coalition for Content Provenance and
Authenticity.
Talking about photos, which is where this whole topic started, and I've seen this for at least 20 years, where the idea was you're going to buy a camera from Canon. This is take a photo, and it was going to digitally sign the photo as soon as the pixels came out of your camera. And it was digital that's been around for 20. And if we're going to talk about C2PA going forward, let's talk about these motivations, because a lot of the same people are doing it. It's kind of like war. There's the Iraq War before 9/11 even started, and then 9/11 happened, and they all jumped in, and then we got the Iraq War, and used that as justification. We were already going to war. If it wasn't 9/11, it would have been 9/12. It would have been something that triggered the people to go to war. That's how wars happen. So the camera, and it would take a photo, and then you would put it on the internet. You would put it on or whatever. Facebook was barely out, and you would put it up there, and then somebody would copy it. And you're like, God, somebody copied my photo. This was the main concern back then. This was a copyright issue. This was a digital products, like selling images. Back when I used to make money from Getty, the predecessors to Getty Images. And I was going to make this photo, and people were going to copy it, and then I wouldn't get my royalties on the photo. So that's a concern for people that sell media, especially people that sell digital media. You make it once, and then you sell it N times. And is one of the concerns. And the way that you would do this is you would put digitography into all the devices that make media. So if you have a camera, you would put a chip inside that would do public key cryptography, or basically, let's just say like that, or basically elliptic curves, and the image. And there would be some magical chip inside that you can't tamper with. And if you did, it wouldn't work anymore. And then sign it. We could all know that if you use that photo, that it was actually taken from this camera on this date. And then on the other end, not the same exact people, but some of these people also want your monitors to have chips in them, so that if you have a monitor open, then you can't look at content unless you pay for it. So DRM is on the outside, on the downstream, and C2PA is on the upside. Get back to an origin, and you can trace it to a viewer, then you can trace the money. What are some of the problems that you have with for cameras? Is there a problem with putting a chip in the camera going to have people, the image was taken with that camera? What are some of the problems with that? You can just launder the image, so you can clean the image to remove the watermark or whatever the metadata is. It says all the images that are on your computer must be signed. Kind of weird, because we're 20 years into DRM with a very large industry lobby, and they still can't require DM, and we still have torrents of everything. So piracy is still alive and well. So what else can you do? Well, chip. Can you take apart the chip? You could take apart the chip and you could fake it, so you could fake the signatures. The chips are now good enough you can't do that. I have not heard about people taking apart Apple products to steal the keys that are inside. What's happening? I've read leaked classified documents from the people that would do stuff like that, and I've not even seen them talking about this. They've got much. Another problem with these chips is they're export restricted. Chips, digitally signing stuff is not a universal human right. Digital cryptography is not something you can even export. If you use GitHub, anytime you use a repository, it asks you. And if it's Apple App Store. If you put something in the Apple App Store, it says, does your product use cryptography? And that includes HTTPS websites. So you have to check yes. And it's like, did you get export control restrictions clearance from, the United States export, trafficking in arms regulations? It's like, no, I did not ask for the ITAR export certification clearance for this. And now you're in this gray zone where you have to say you did, but you didn't. What's that about? So you can't have any security in a product without the U.S. government, if you're in the U.S. exporting, without the U.S. government saying so. Not on how it works for imports, not about Japan and sending it from Japan to China. The world is not on one standard for cryptography. And the borders have some special things, like you can't move cryptography across borders. So I'm just saying, under Clinton, called the Clipper chip, bits of encryption. So if you remember the old days with Wi-Fi, you could crack them because you could just brute force them, because there just were only 40 bits of encryption, because anything more than that was illegal under Clinton. Sorry, I'm going back. Okay, so now let's bring this forward. So just practical matter of why you would not want to sign the bits coming out of your photo. Why don't you want to sign the bits in the pixels coming out of your camera? Because it publishes the bits and pixels coming out of their camera. Nobody takes the stuff that comes out of their camera and puts it, no, they don't go anywhere. It's the pixels that come into an iPhone and publishes them anywhere. In fact, you don't even see the pixels that come out of the camera. When you're using an iPhone or an Android camera, you look at it on the screen photo, the thing you're looking at is not what's on the other side of the lens. There is so much happening between there. Android phone and you zoom in on the moon, you're looking at a picture of the moon past the actual thing you're looking at. If you're in China, if you're at any website on China and you're looking at a woman, her eyes are 40% larger and her face is 30% slimmer. As soon as you're looking at it, even if you got the camera in your hand looking at the girl, 10 slimmer in the photo. The photos are doctored on the device as it's coming out the other end of the device. So sign it coming into the device doesn't even make sense. As soon as you alter the photo, it's no longer signed because this is how digital cryptography works. As soon as you alter it, it's no longer viable. So people are altering things all the time, especially images, because look, they don't like the lighting, the thing has to be corrected, you have to Photoshop, you have to Lightroom it, color correct it, and the raw images. Unless it's a medical application or a legal application or a it's surveillance, unless it's one of those applications, surveillance, legal, or medical, it's doctored. Evidence in court. Any photo of your phone as evidence in court. Cases that are not stand-upable in court. I mean, maybe you can convince a jury, but the defense can always say, look, the photo that you took is not what you saw. Then you can use that as a defense.
Here they're trying to make is for, I guess, a finished product of image or an article or something that's not going to.
Right. 2PA in this specification there does talk about encoding or signing images at the time of collection. That would be the pixels coming into your camera. They also talk about at the time of publication.
Even time of collection is planning on.
I don't know if it's planning or that's a spec or whatever, but
yeah,
that's in play.
ARM and Intel are part of this, so pretty low-level things in mind.
Yeah, they already have trusted compute modules similar to the product. You're going to publish it, so you want to sign it. That you can't alter it, you can't stream it. It's got to be like the original format. You can't transcode it, you can't upscale it, downscale it, retime it.
And paint it in a positive light. They don't want to inhibit remixing. They just want provenance in remixing.
This gets you that. Well, because this is a tamper evidence sticker. So when you place on Earth that you think the most people are focused on watermarking video, and where there's the most money coming in and out of the platform, and where there's the most people remixing video.
People remixing video.
People taking
YouTube?
video. Yeah, YouTube. And so it's called Content ID. YouTube, you could find that there are always people that have found some way to get the latest episode of South Park and Family Guy on there, even though it's banned. They're very creative. Kids are extremely creative. It's called Advanced Persistent Teenager. So they work on this and they try every angle. And the way they do it nowadays is they take every 20 seconds, they jump 5 seconds and then they retime it. And this is it's undetectable from Content ID. Some people are on YouTube and they just want to watch the latest episode of Family Guy. I'm on YouTube watching the latest episode of Family Guy because I want to see how are they getting around the Content ID watermarking. What is the technique? And they always have it. So I just want to say is that no matter how many lawmakers and people from Adobe, Microsoft, ARM, and Intel you have working on this, whatever they have is going to not be as effective as YouTube has with eyeballs, teenagers, and content already on it, like the ability to upgrade. Because as soon as Microsoft, Intel, ARM, and legislators make C2PA, it's going to be fossilized right away. You can't get better. And then they're going to make interoperable tools on how to detect the watermarks, which means you can just make interoperable tools to the watermark beyond recognition. So the threshold is lower for getting past that. If you mangle something on YouTube, then YouTube just updates itself and then it gets those. It's a cat and a mouse game. with YouTube. But with C2PA and legislators, it's a cat and a mousetrap game. The mousetrap is dead and it's always in the same spot. And the mouse just walks around the mousetrap. It is, we know what it looks like, and it's not chasing you. I think I'm quoting Ender's Game here. I think I'm never know your weakness until you have an enemy. And
so then if it's essentially dead on arrival, why are they doing it anyway? I mean, I think this still has potential for success in the eyes of the developers, in the sense of if they can use regulatory methods to like force capture of, you know, some of the marketplace for media and ideas, because, you know, that's still a win. You know, it's they get the of things that happen on the internet that they're interested in to some extent. And it's if YouTube doesn't shut down audio just because, you know, some people are gonna break rules and get away with it, so that, you know, of the broad swath of usage, they're able to steer towards the direction that they want. And so maybe that, like, this is would look like for this project from the creators.